Let's do checkpoint 6.23. Calculate the work done by the field f of xy equal to 2x, 3y on the particle that traverses the unit circle. Assume the particle begins its movement at -1, 0. They did not specify whether we should be going in a clockwise or counterclockwise direction. They did give us a starting point. So if we graph our unit circle and figure out that we want to start at -1, 0, again, they don't specify whether we're going clockwise or counterclockwise. So let me just make some assumptions and say, let's just go clockwise so we can keep our original parameterization, the original polar coordinate parameterization, cosine t, sine t. And since we're starting not at our standard starting position, we're starting here, let's make our t go from -pi to +pi. That should traverse the unit circle starting at 1, 0. Now the work done for of a vector field traversing along a particular curve is going to be given by the line integral over that curve vector field dr. And so this is a dot product. And we know our working definition already, and that's equal to the integral from a to b, whatever a and b are, of the vector field evaluated at the parameterization dotted with the derivative of the parameterization dt. So let us find those pieces. We'll figure out what f of r of t is. And f is equal to 2x, 3y. So that's 2, and our x is cosine t. 3 times y is sine t. And that's it. And r prime is the derivative. R prime of t is equal to a derivative. Derivative of cosine is negative sine. Derivative of sine is positive cosine. And there we have it. We should be ready to put it together. Our work is going to be equal to the integral from -pi to pi of 2 cosine t, 3 sine t, dotted with negative sine t, cosine t dt. And here we have -2 sine t cosine t plus 3 sine t cosine t. So this is just going to be 1 sine t times cosine t dt. I think we could do this with the u substitution. If I let u equal the sine, this will remain positive. So u equals sine t du equals cosine t dt. So we get to replace this whole thing with du. And then we would have the integral, and these are still t limits, -pi to pi of u, that's sine t, and then du. So this will give us a 1/2 u squared. And again, the limits are still t limits. So let's change it back to sine squared t from -pi to pi. All right. Sine of pi is 0. And the sine of negative pi is also 0. So this looks like it has no work total. And again, it's this is probably going to be one of those vector fields that what we call conservative. A theorem that we're going to see later on tells us that if we're going to integrate a line integral of a conservative field over a closed curve, then our integral is going to be equal to 0. Okay? And again, this did not tell us how the orientation should go. Usually that's an important piece of information, but because they didn't tell us, they are probably assuming that we're going to end up with 0 anyways. Because the difference between the orientations is that one is going to give us a positive, one's going to give us a negative, or opposite signs. Okay, I hope that helps. Good luck.